So remember, you might encounter a logarithmic equation in one of two forms. So we've already looked at the situation where you get an equation and you're going to be able to write it as a single logarithm equal to a number. You may have to do some condensing along the way. Now we're going to talk about the other situation. You might get a logarithmic equation that can be written in the form log base A of u is equal to log base A of v. Okay, and like I said, how to translate that, you're going to be able to write your logarithmic equation in the format where it's one logarithm equal to one logarithm and they have the same base. Okay, remember in the other situation, it's one logarithm equal to a number. Now it's one logarithm equal to one logarithm where they have the same base. Okay, so let's read through the directions for this particular situation and then do some examples. So in step 1, you're going to condense the logarithms on the left side of the equation into a single logarithmic expression using those three major properties of logarithms from section 6.5. You're also going to condense the logarithms on the right side of the equation into a single logarithmic expression. It is not necessary to move all the logarithms to one side of the equation. So step 1 should have resulted in an equation of the form log base A of u is equal to log base A of v, meaning you have one logarithm on the left side and one logarithm on the right side, and they have the same base. So now what you're going to do is set the arguments equal to each other, meaning set the quantity u equal to the quantity v. Okay, so you're going to take, once you have one logarithm equal to one logarithm and they're the same base, you're going to take the things that you're taking the logarithms of and set them equal to each other. And then in step 3, you're going to solve for the variable x or whatever variable you're using. Okay, again, since these are logarithmic equations, you need to check the solutions in the original equation and exclude any solution that leads to you taking the logarithm of a negative number or of 0. Okay, so let's give it a shot. In example 2, it says solve each logarithmic equation. Express irrational solutions in exact form, no decimals, and as a decimal rounded to 3 decimal places. All right, in part A, the logarithmic equation is log base 2 of 5 plus log base 2 of x minus 3 is equal to log base 2 of x plus 5. All right, so something to notice here is that there's 3 different logarithms involved. They're all base 2. So you could theoretically move them all on one side and then condense the logarithms into one and then have a logarithm equal to a number. Okay, so that's perfectly fine. Okay, the easier thing to do here, okay, is on the left side, I have 2 different logarithms. We can combine them into one, and then we'll have one logarithm equal to another. Okay, so I think that's the easiest approach. So that's what we're going to do here. Okay, so we are adding the 2 logarithms. They're both base 2. We can combine them. So remember, addition turns into multiplication. So on the left side, this is going to be log base 2 of, take the things that you're taking the logs of and you're going to multiply them together. It's going to be 5 times the package deal x minus 3. So you need parentheses around the x minus 3. Okay, so that's how you're going to condense the logarithms on the left side. And then we're not doing anything with the log on the right side. Okay, so going forward, okay, I'm going to look at the logarithm on the left side and I'm going to simplify what we're taking the logarithm of. Okay, so this is going to be log base 2 of, I need to distribute the 5. So this is going to be 5x minus 15. Okay, so that's the logarithm on the left. That's got to equal, again, no changes to the log on the right side. Okay, so now look at what we have. On the left side, we have log base 2 of 5x minus 15. On the right side, we have log base 2 of x plus 5. Okay, both sides of the equation are log base 2 of something. The only way the two logarithms can be equal, since they're both base 2, is if the somethings, the things that we're taking the logarithm of, are equal, okay? So we're going to take the 5x minus 15 and set it equal to the x plus 5, okay? So we can kind of drop the logarithms here. 5x minus 15 has to be equal to x plus 5, okay? This is now a linear equation. Logarithms are gone, okay? The highest power of x in the whole thing is the first power. So all we need to do is isolate the x. So put everything with an x on one side and all the numbers on the other side. So I'm going to start by moving this x from the right to the left side. So since it's positive, I'm going to subtract x from both sides. Okay, this is going to tell me that 4x minus 15 is equal to 5. Okay, and then move the 15 over. So I'm going to add 15 to both sides. I'm going to get that 4x is equal to 20. Divide both sides by 4. And so the answer here is that x has to be 5. Okay, again, this is logarithmic. We need to check ourselves, okay, just to make sure that x equals 5 is a viable solution. So go back to the original equation. Make sure that plugging in x equals 5 does not cause us to take the logarithm of a negative number or of 0. Okay, so a quick check here. If you look at the first logarithm, there's not even an x involved, so you're not even plugging in. On the second logarithm, there is an x, so let's see. If we're going to get log base 2 of x, which is 5, minus 3. This is going to be log base 2 of 2, okay? You're taking the logarithm of a positive number, so you're going to be fine here. All right, so moving on to part B, okay? Now we've got natural log involved, okay? Notice you've got logarithms on both sides of the equal sign, okay? So your goal here is to condense the logarithms into one logarithm on the left side and one logarithm on the right side, okay? So on the left side, they're both natural logs, so we're going to combine them into one, okay? So again, we're adding here, so we're going to need to addition will turn into multiplication. All right, so we're going to get the natural log. We're going to keep the same base, okay? And the quantities that we're taking the logarithms of, okay, we need to multiply them together. So this is going to be the natural log of the package deal x minus 1 times x, okay? That's how those guys combine into 1, okay? We're not doing anything to the right side. The right side is a single logarithm, okay? So we don't need to combine it into one, or we don't need to combine it with anything else. It's already one logarithm, okay? Now on the left side, we're going to simplify what we're taking the logarithm of. We're going to distribute the x. So it's going to be x squared minus x. So this is going to be the natural log of x squared minus x. That has to equal the natural log of 2x. And now look at what we have. On the left, we have the natural log of x squared minus x. And on the right, we have the natural log of 2x. So we have one logarithm equal to one logarithm, and the bases are the same. So the only way this statement can be true, the natural log of something is equal to the natural log of something, is if the somethings are the same, okay? So we're going to take the x squared minus x and set it equal to 2x, okay? So x squared minus x is equal to 2x, okay? So the logarithms are gone, okay? If you scan this equation, the highest power of x is 2. So this is a quadratic equation, okay? So to solve a quadratic equation, we need to either factor or use the quadratic formula. Regardless, we need to make one side 0 before we start, okay? So I'm going to move the 2x over, okay? So we're going to get x squared minus 3x is equal to 0, okay? So we need to either factor the non-zero side or use the quadratic formula, okay? This is very simple to factor. I'm going to take out an x. That's going to leave me with x minus 3, okay? And you can distribute the left side back out just to check yourself, okay? If you did distribute it, you would get x squared minus 3x. That's what we started with, so that's how it factors, Okay, so now we need to take each factor, set it equal to 0, and solve. Okay, so remember, factors are the things that we're multiplying together. So x is a factor and x minus 3 is a factor. Okay, so we're going to set x equal to 0. Okay, that's already solved. So that's going to be one of the potential solutions. And then the other factor, okay, x minus 3 is equal to 0. So if we solve that, move 3 over. So we're going to get x equals positive 3. Okay, so we have two potential solutions. We need to go check in the original equation to make sure everything works out. Okay, let's first check x equals 0. Okay, so plug it back into the original equation and see if you have any issues. So we're going to get the natural log of 0 minus 1. As soon as you do that, you see the natural log of -1. You cannot do that. Okay, you can't take the logarithm of a negative number. So this is bad, bad, bad. Okay, we're going to have to go over here and we're going to have to exclude 0 as a solution. Okay, this is an extraneous solution. It looks like a solution, but it actually isn't. Okay, so let me put here, this is extraneous. Okay, now let's go and check the other solution, x equals 3. Okay, plug it in. We're going to get the natural log of 3 minus 1 plus the natural log of 3. Does that equal the natural log of 2 times 3? Okay, that's going to be the natural log of 2 plus the natural log of 3 is equal to the natural log of 6. We're good to go here because we're taking the logarithm of positive numbers in each piece. Okay, so 3 is going to be, x equals 3 is going to be the only solution for this equation. Okay, so let me write here, this is the only solution.